Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called City of Whispers by Jay Dyer. And here are the rules. We have, normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have adjacent digits on lines differ by at least 5. People know this usually as German whisper lines. I call them whisper 5 lines because a setter came up with that designation, and I thought it made sense because it's very easily extendable. So, for example, on the whisper 5 line, if this were, say, 3, this would have to be 8 or 9 because those are the only digits which are 5 or more away from 3. And that's how these whisper 5 lines work. Digits outside the grid are skyscrapers clues. And I guess that's a misspelling? Or maybe there's a different way of spelling skyscrapers now. That's an actually interesting way of spelling it. Which means that the clue equals the number of digits in that row / column which is visible from the clue's end, where higher digits block the view of lower digits behind them. So let's just give an example. Say this was, I don't know, 2, 3, 4, 2, 8, 5, 7, 1, 9, 6. Then the clue outside here would have to be, it sees 3, it sees 4. It does not see 2 because that's blocked by the higher digits in front of it. It sees 8, it does not see 5, 7, or 1, and it sees 9. So therefore, if this were the actual setting of the, if this were the actual digits in the puzzle, this would have to be 4 outside here. Because these digits, this clue, seeing the numbers this way, would only see 3, 4, 8, and 9. 2 would be blocked by 4, 3 in front of it. 5, 7, 1 would be blocked by the 8 in front of it. 6 would be blocked by the 9 in front of it. So that's an example of how skyscraper clues work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. What does this mean? Okay, so this, we know 5. So first of all, skyscraper clues are going to be 1 through 9 because you can't see more than 9 cells in a row, and you can't see less than 1 cell in a row. So also, 5 can never be on a whisper 5 line, because if you subtract 5 or more from 5, you get 0 or less. If you add 5 or more to 5, you get 10 or more, neither of which are digits. But also, outside of the grid, you can't have a clue be greater than 9 or less than 1 either. So therefore, you're guaranteed to not have a 5 anywhere on these lines. And you must alternate between low digits and high digits because I've said it many times in Learn How to Sudoku puzzles and other puzzles too. So if you want to understand the reasoning why you have to alternate between low and high digits on a Whisper 5 line, check out any of my Whisper 5 puzzles, particularly on the Learn How to Sudoku section. So these have to be alternating high-low variants. So the interesting thing there is, my question is kind of how many highs and low digits can you have each here? So say Say this was low and low. That would guarantee these are both high. And does that tell us anything? One thing you know for the skyscraper clues is only one at most of the digits outside can be 9. And only one at most can be 1, right? Because to make sure you have 9, that would mean you'd have to see all the digits in the row or column, which means you would guarantee see 1, 2, 3, 4, 5, 6, 7, 8, 9. But then if you have another 9, it would be the same thing, and you'd have a repeat in a row here. Same with 1. If you see only 1, that means guaranteed 9 is the digit here, but you can't have another 1 here. So 1 and 9 cannot be repeated in skyscraper clues outside of the grid in the same row or column. That's interesting. You could certainly have 2. That works perfectly fine. You could have repeats of 2. Can you have repeats of 8? You could even have repeats of 8. You just can't have repeats of 1 or 9. Huh. So this is next to 2 unique digits because, well, actually, it's not true. It just can't have 2 1s, and it can't have 2 9s, which does limit that you can't have 4 or 6 here, right? Because you can't have them next to 2 unique digits here, and they would have, or 2 non 1 or 9 digits here. One of them could be 1 or 9, but the other one has to be something different. So therefore, this cannot be 4 or 6. It's 1, 2, 3, 7, 8, 9. And it's the same thing here. That's interesting. You have the same problem here. If this is 9, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But if this is 9, this would be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'd have 2 1s here. 2 here matches fine, but then you have 2 3s here. Obviously, you can't have duplicates in the same box. Same thing, this cannot be both 1s. That would force 9 to be here and 9 to be here. We'd have a duplicate there. So this also has to be 1, 2, 3, 7, 8, or 9. Right. This is 1, 2, 3, 7, 8, 9. It's next to 2 unique digits on a Whisper 5 line. Same here. This has to be 1, 2, 3, 7, 8, 9. Because they're next to 2 unique digits on a Whisper 5 line. This also has to be 1, 2, 3, 7, 8, 9. Because, again, you can't have 2 1s or 2 9s here. 1, 2, 3, 7, 8, 9 here. Oh, this is interesting. This cannot be both. So if this is high, this has to be a low, right? If this sees 7 digits, that means you're not going to see that many digits this way, right? If you see 7 digits this way, that means all of 5, 6 of these are going to be lower than the digit here, which is the last one. So this C is going to be low. So these are opposite. How do you say it? Opposite high-low sets. So I guess we'll mark this as yellow, and we'll mark this as pink. Therefore, these must both be pink. And this must be yellow. And we have something similar here, right? Well, this could be 4. And you could have a 4 there, potentially. No, because if it's 4 and 4, then this becomes 9 and 9. And that's not going to work. These are both yellow, which makes this pink. Does this have to be opposite? These have to definitely be opposite because they can never have 4 and 6. And once you see well, that's not true. You could see 3 here and 3 here. Okay, so that's not necessarily true either. So you could see low amounts and low amount here. That could certainly be the case. Hmm. Hmm. Okay, that I take that back. That's not the way to approach it then. Um, we know though that these two are the same. So let's mark. So yellow, yellow. This is pink, pink. This is, well, this is either the opposite or they're two lows. What we know then is if this is high, this cannot be two highs here, right? Because one of these has to be 6, which means you can only see one cell here. 6 has to be next to 1 on a Whisper 5 line, which guarantees that only sees one skyscraper, so that has to be 9, but we have 4 highs in this row, if that's the case. So that doesn't work there. And you can't have 4 lows either, because you're guaranteed that one of these is 4, which must be next to 9, which guarantees this must be 1, 2, 3, 4, 5, 6, 7, 8, 9. Which is, if we have 4 lows, that's not going to work. So these must be the opposite. This cannot be 4 of the same set. So these are pink, which makes this yellow. That's interesting. Hmm. If you have 4 here, that would force 9 to be here. So that would be 1, 2, 3, 4, 5. Okay, so this can never be 4 here. If that's 4, that forces 9 to be there. 1, 2, 3, 4, 5, 6. And this can't be 5 or 6. Can't be 5 here. So this cannot be 4. Can it be 6? Yes, because that could be 1 and that could be 9. That's certainly possible. So this is 1, 2, 3, 6, 7, 8, 9. Can this be 4? 4, 1. So 4, 9 means 1, 2, 3. No. Oh. Right. 4, 9 means this is 1, 2, 3, which eliminates 1, 2, 3 as possibilities here, which would mean this is 7, 8, 9, but that's not 5 or more away from 9. So this can't be 4 either. 6 works because then you could have 6, 1. That's 9 there, and this is a high digit. So this is also 1, 2, 3, 6, 7, 8, 9. Huh. Can this be 4? If this is 4, again, that makes this 9, which means you see 1, 2, 3, 4, 5, so no. Oh, so this can't be 9, because that would force this to be 1, 2, 3, 4, 5. Same here, 1, 2, 3, 4, 5. So this can't be 9 either way. Can it be 8? I don't know if it can be 8 either. Right? Um, this is 1, 2, 3, 4, 6, 7, 8, and 9. So how do you see 8 here? So 5, where would 5 be? If you have 5 here, you cannot see it above this cell. But then the problem is that this is not going to form some sort of set that works well that way. Right, how do you see 8 here? So if this is 8, these are both low, which means you have at most 2 other lows here. So this would have to be 5 or higher. And you would guarantee see 1, 2, 3, and then 4 more here, which means this cannot be 8. You could have 7 here, maybe. If this is 7, this is 1, 2 as a pair. So this must be 3, 4, 5. And then you see 6 in order. 7 with 1 or 2. And then 8, then 9. That's possible. Can you see 8 this way? If you see 8 here, this again is low and low, so you have 2 lows here at most. This is 5, and then you see 4 other cells, so this cannot be 8. Interesting. If this is not... Okay, this can never be 9 either. If this is 9, you see 1, 2, 3 here, and this would be 7, 8, or 9, which is not next to a 9 here. So this cannot be 9 here. Can this be 9? No. If you see 9 there, it's 1, 2, 3 here, which makes that 7, 8, or 9, and it's not a high. So this is 1, 2, 3, 4, 6, 7, 8, possibly. I think you have the same problem if you have 8 here, right? If you have 8 here, that means this is low. I guess this is low. Right, so if this is 8, this is low, that's low, which means you have 2 lows here at most, and a 5 here at best, which means you see at most 7 cells. So this cannot be 8 here. You could have 7 here. You could have 7 here. So this can, okay, so this is, if this is high, it's 7, which means this can never be 3 here. If this is high, it's 7, which means this can never be 3 or 4 here. So this could be 1, 2, 6, 7, 8, and 9, potentially. Can you ever have 7 and 7? I think the answer to that is no. That means there's 2 lows here. You could have 2 lows this way and 5, but then that would mean this can't be 5. So this can't be 7. Can you have 6 here? So if these are high, it's 6 and 7 here, which would force 1 to be here and 2 to be here. Does that work? So say we have 6 here, 1, this is 2, 7. You have to have 3, 4 here. So 3, 4. That would force this to be 5. And that could see 7. But this is guaranteed to have 6, 7, or 8 here, which means this cannot be 2 highs. So this has to be low here and low here, which makes this high and high. Interesting. So no 1 here, no 2 here, no 7 here, no 6 here. So this sees 1, 2, or 3. You have to have 1 high here. Because, well, you don't have to. You could have like 5, 1, 2, and then something. That's also possible. Okay. Hmm. If you have a 7 here, what does that imply for this? If you have a 7 here, that's 1, 2, 1, 2. You cannot have an 8 here or a 9 here because both 1 and 2 can't be here. So you're seeing 3 or higher here, which is going to be higher, that means you see 7 cells at most here. Oh, but you could have 2 7s. Right, you can have 2 7s there. So that could work. No, that doesn't work. You can't have 2 7s because if you have 7 here, that's 1, 2, 1, 2, which means this has to be 3, 4, 5. But then this can't have a 3, so it would have to have a 4. So if this is high, it sees 6. That's interesting. So this could be 1, 2, 3, 4 there. So what happens if that's the case? So 7, this becomes 1, 2, 1, 2. This has to be 6. So this sees 3 here, 4 here, 5. One of these is high. You cannot have 3 highs here because of 6. So one of them's high here. So if you see 6 here only, that doesn't work. So one of these must be 7, 8, or 9. 7 has to be here, which means this is 6. This sees... has to be 7 here. So it's 7 with 1 or 2. You have 8 and 9 here with 1 or 2. So this is 1, 2, 8, 9. Obviously, that can't be 9. This can't be 8. So 8 and 9 are here. This can't be 8 or 9. It's 7, which means this cannot be 3 or 4. There's no 3 here. It sees 1 or 2. This can't be 8 or 9. It's 6, which forces this to be 1, which means this must see 9. So 9 can't be here. This sees 1 or 2. Cannot see 1, so this must be 2. And therefore, this can't be 8 because the remaining digits... So this could work. Are 3, 4, 5, 1, 2. This must see this cell and not this cell. So this can't be 8. This is 8 that way. This has to see 4. So again, no 1, 2, 3 here, no 1, 2, 3 here. This cannot be 1 because that would then see 2. This can't be 5 because if that's 5, it would not see that. This has to be greater than both of these. So this sees that, and then it sees the 9 next. That is possible. So this is 6, 7, 8, 9. No, 7, 7, 8, 9 here. This is possible. That leaves the remaining digits in row. These are both high, which makes this low. This sees 1, 2, or 3. So this is 7 with 1 or 2. If this is 7, this has to be 1 or 2. If it's 1 or 2, it could be, can't be 6, can't be 7. This is 8 or 9. So far, this is looking okay, right? This sees 2. This sees 1. If this is high, it's an 8. If it's low, it has to be 1 through... It could be 1 through 4. This no longer can see 9. This can't see 9 either. So it sees the 9 in front, so it's at most 6 cells that it sees, because it can't see 9 here. So this cannot be 7 or 8. It's 1, 2, or 3, which means this is low. This has to be high. So it's 6 through 9 here. Obviously cannot be 9, because we have a 1 or 2 there. Cannot be 8, because we have a 9 in front of this. This has to be 6. So we have this 6, 1, and 1, which means 9 is there. 9 has to be here. It must see 4, 5, 6, 7, 8, 9. Which means this can't be 4, 5. That's 3. This is 1, 2 as a pair. So far, that looks okay. No 3, 4, 5. We have 1, 2, 1, 2 as a pair, which eliminates 1, 2 here, so it's 8 and 9. Which means that's high next to a low, which means this is 7. So that's okay. 9 cannot be here. 6 can't be here. This is all looking fine. You have 1 through 3 there. This has to be 7, 8, or 9. It could be 6, actually. Forgot about that. You can have repeats. Outside the grid. Remaining digits in column 3. We have 3, 4, and 5. Seven eliminates 7 here. This can't be 8. So this cannot see just 1. So this has to be 2, 3, or 4. This is looking like the solution, actually. But, it could see 6 this way. 9 cannot be here, and 9 can't be any of these, so 9 would have to be here. So this would be 9, which would make this 8, which would make this not 8. This is looking like the solution, but... So it sees the 8 in front of this. So I'm thinking that we should try to look for the other contradiction then. What happens if... So can we ever have this be low is the question. In... Can this be low? Obviously, you can't have 1 and 1. So that's obviously not going to work. What other ways can work here? Okay, let's just start from 3, and then let's go down. So if we have 3 here, this has to be 8, 9 as a pair here. These have to be low, then. Means these are high. This also cannot be 9 here. So this would be low. This cannot be 9 because then that would force 1, 2, 3 here. And Can this ever be 8? Maybe. This can't be 9 though, so this is 6, 7, or 8. If we have 3 here, you could potentially see 3 this way. Remaining digits in row 1 are 1, 2, 3, 4, 5, 6, 7. Okay. This cannot be 7, 6, 5, or 4. It has to see at least. So this is 1, 2, 3 as a triplet, which eliminates 1, 2, 3 in the rest of the row. So this cannot be. This is at 6 at least. It sees. So this has to be 4. Because if it's greater, then it sees less than that. So 4 cannot be any of these. Okay, so this is 4. This is 1, 2, 3 is a triplet. That means this sees 6. So since this is 6, that's 1, which eliminates 1 in the rest of the row and box. If this were trying to be 8, it would see 2, 3, and then it would see a high digit, which is not possible. If it saw any other digit, 2, 5, that could not see 8. So this would be 7 then. This cannot be a high digit. Because if it's a high digit, then it would see 1, 2, 3, 4, 5 cells at most. So if that's the case, this has to be a low, which means it sees this, it sees 5 at best, and that's too few. So that's the reason why this cannot be low. And we've gotten contradiction there. Because this sees 1, 2, and then 6, 7, 8, 9, which is only 4. So that's too small. That's the reason why we know that we were going down the right path. With the pinks here being high instead of low. So the pinks are high, and the yellows are low here. Therefore, this is 7. This has to be 6. So it's no, this is 7 or 8. This is 1, 2, 3, 1, 2, 3. This is 1, 2, next to both 7. That means this must see 3, 4, 5. This must be 4. The rest of row 1 is 5 through 9. Because of this, we know, again, we can't have 3 high digits here. So there must be at least a non-high digit here. We have to see then 8 and 9 here, at least. We'll see 1 high digit here, and we must have a high digit here. So this has to be in order, 6 and then 7. So this is 7 with 1 or 2. Therefore, this is 1, 2, 8, 9. 9 can't be here. 8 can't be here. 8 and 9 guaranteed here. Means this can't be 8 or 9. It's 7. This can't be 7, 8, or 9. So this must be 6, which makes that 1. Since that's 1, this sees 9 here. This cannot see 9 here. This has to be 2 to be 5 or more away from 7. So that's 2. Therefore, 8 cannot be here. Because if this is 8, it sees this cell and 8, and then 9 remaining in the row. So this has to be 8 here. Yeah, and everything we were showing still works fine. So this is 1 through 4. We try to have, well, I don't remember exactly how I did this. So this is 1 through 5. 1 through 5. This can't be 1 because it would see 1 and 2, and then 9 guaranteed. This can't be 5 because it would see this digit 5 and 9 guaranteed. If this is 7, this would have to be 1 or 2. If this is so this has to be Right. So we tried to make that 8. How did we disprove that? Okay, so if this is 1 or 2, if this is 1 or 2, this has to be 8 or 9 because it can't be 6 or 7. This had to be 6, 8, and 9, and this was 7, 8, and 9. Right. Oh, that's the reasoning. This has to be, well, this has to see a 9 here. So this can only see 6 digits at most. So this cannot be high. That's the reason why. So this is low, which makes both of these high, which makes that low. So this means 9 can only be here, and it must be C4 through 9 there as a high digit, so that's 6. This could be 6 or 7, we're not sure which, or 8 and 9 technically. This 6 can only be next to 1, so this is 1, that's 1, which means the 9 is there. This sees 4, 5, 6, 7. Actually, that's not true. This can be 9. Okay, so that was actually incorrect when I was doing that. It has to see 8, though. So it's 8, 7, because we're guaranteed that we have to see the low digit here. It does not see any of these 3. It must see every single one of these. And if we have 8 or 7 in an earlier spot, then it will not see the other digits, right? So if we had 8 here, that would block 7. Or if we had 7 here, that would block these cells. So all of these cells must be seen, which means this must be 8, 9, 8, 7, and then 6. But these could be whatever. These do not have to be 4 and 5. So that's not a contradiction. Okay, so let's keep that in mind. This cannot be 9 because then that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. This 9 here means this can't be 9, so this can't just see 1. These are 2 through 5 here. We are guaranteed a 1 in row 8, so 1 has to be one of these two, which means this cannot be 1 here. This sees 4 through 9. That means it does not see any of these because it must see an 8 somewhere here. It must see a 7 somewhere here. It must see 6 and 5 somewhere here. So 8 has to be, so it has to see a 5. So it can see 5 here, 6 here, 7 here, and 8 here. And that is the extent of it. So 5 is one of these two, which means this cannot be 5, which means 5 has to be one of these two in row 1. 6 is one of those two, 7 is one of those two, 8 is one of those two. This can't be 6. So since this can't be 6, where does it see 6 in column 4? It must see 6 here. Also 5's there, yeah, so 5 has to be there. These cannot be 6, which means this is 7, 8, and 9 as a triplet, which eliminates 7, 8, and 9 in the rest of the row. So this is 5, 6 as a pair. We have 7 guaranteed as one of these two, 8 guaranteed as one of those two. So we have 7, 8, and then the rest are 1, 2, and 3. This can't be 1 because of 1 in the row. Seven eliminates 7 here. 8 eliminates 8 there. 6 eliminates 6 here, so this is 5, which makes that 6. This cannot see one digit. So it's either 2 or 3. This is 2, 3, or 4. It still could see 6, 7, and 8. This cannot be 2 then, because if this were 2, that would see 6. You guaranteed 7 or 8 here. So that you will see, because 7 and 8 cannot be there. So this must be 3 at least, which means this can't be 7, which means we have an 8, 9 pair in row 1, which eliminates 8 and 9 in the rest of the row. This can't be 8 or 9, it's 7. 8 has to be one of these two digits here, because it cannot be in this box. Remaining digits of box 2 are 1, 2, 3, 8, and 9. 8 cannot be any of these, though. We don't have this information anymore because this could still be, oh, this has to be greater than this one. So this can't be 2, this can't be 5. Because it must see 6 cells here. 9 cannot be any of these digits here. So 9 in row 6 has to be one of these two because it must see at least 6 cells, right? If 9 is any earlier, it would not see 6 cells. This sees 2 or 3. Still possible. 6 cannot be here, so where's 6 in this box? It must be there. We have... No, we don't. We know 4 has to be one of these two. That's not too helpful. Remaining digits in row 2 are 1, 2, 3, 7, 8, 9. No 1, 9 here. Yellow, pink. Yellow, pink. I guess we'll make this dark and medium. If these are high, that's interesting. Then we have all the highs accounted for in row 4. Oh, 9 cannot be here. If this were high. Okay. This could be two lows, though. Seven has to be one of these two digits here. 6 has to be one of these two digits here. So if this is 7, this is 7 here. If this is 7, this would be low, low, 8, 8, 7. Can this ever see 8 cells? Maybe. No, it cannot. If this sees 8 cells, 9 would have to be here. The problem is either 8 would be here, or you're not seeing both of these and this is 8. Then that would see 7 cells at most. So if you had 8 here, that would be 1, 2, or 3 there, which means it's guaranteed to not see that cell and that cell. So therefore, that's why this can't be 8. So this is 6 or 7. Bull. Do we have restrictions if we have a 4 there? That's what I'm thinking. Maybe, maybe not. If these are low, these could be 1 through 4 technically. If they're high, this can't be 6 or 7. This would be 8 or 9. And this could be 7, 8, or 9. That's not too helpful. Remaining digits of row 9, we have 2, 3, 4, 5, and 8. 8 can obviously not be there. Remaining digits of row 7, we have 1 through 7. No 7 here, no 6 here. No 1 here. Okay, no 5 in either of these spots. So we're guaranteed a 5 here in one of these 3 cells. So where's 5 in row column 9? It must be one of those 3. Is that helpful? I'm not sure. Remaining digits in column 9. We have 2, 3, 4, 5, 7, 8. No 5 here. These are all fine. Okay, so this sees 9 and it sees this must be greater than this cell. So this can't be 2. This still could be 5 and 4 there. That's possible. So that's done. 1 cell sees 9. This sees 3, 4, 5, 6, 7, 8, and 9. That's fine. This sees 4, 5, 6, 7, 8, 9. So that's fine. This sees any of these, both of these digits, 6, 7, 8, 9. That's fine. This sees 9, which is 1. 6 or 7. Can it see 7? So if we try to have this as 7, then it would be 2. Would it have to be 2 is the question. So it cannot see either of these. So then, or it does not see either of these. It can't see 9 and then 8 here, and then it would... So either way, it does not see 2 out of the 4 of these. So it has to see all of these. Obviously, you can't... Okay, so first of all... it cannot have 5, 7, or 8 there. It's 2, 3, or 4, guaranteed. It cannot... Can it have 4 here? If you don't... Well, okay, so you can't have 5 here. That means... Can it be 4? If it's 4, you have to see 5, 6. That's just not going to work. So this can't be 4 here. Right, 5 can't be either of these because 5 is guaranteed to be one of those two in this box. So you would have to see 5 there, and that's problematic. Okay. Hmm. Can this be 7 here? Yes, it could be. Hmm. This is not helpful. Guess we need to figure out this skyscraper probably. Um, 1, 2, okay. So if it's 7, it's missing 2 out of these 4. If it sees both of these, it has to see 8 and 9, because it can't be 7 and 9. If it sees 6 here, that means 8 is in front of it, and therefore it would not see both of these. So if it sees both of these, this is 8 and 9. It would not see that, it would not see that. So you would have to see these 5 cells. If it sees, so if this is 8, it doesn't see that. Otherwise, this is 8. Maybe let's just go through the scenarios of when if this is high or this is low. Say this is 8 and this is 7. That would make this low, 7, low there. So this would be low. It would not see any of these, so it has to see all of these. So then this would be 9, 8. It would have to be in some order here. This is 2 or 3, which is next to 4, 5, and then we'd have a contradiction because we can't have 5 in there. So that does not work. So this cannot be 7 here. This has to be low. So pinks are low. Well, actually, that's not true. We just know that can't be 8. Because if this is 8, that forces that to be 7, and that has that problem. So therefore, this is 8. It must see 9 here. It does not see any of these. So 5 cannot be here. Because if it's 5 here, 5, 4, 3. Oh, I guess it could be there. This can't be 5 or 6. Hold up, why didn't that work? Okay, so again, let's try to make that 8, 7. This is not 8. This is 7. This can't be 7 here. But it doesn't have to see 7 digits here. So this is not, and one of these is 9. This is 1 or 2. No 7 here, no 8 here. Oh, that's another thing. We know if this is high, it cannot be 8 or 7 because of 7, 8 in the box. So this has to be 9 in that instance. If this is high, it cannot be 9. Interesting. Yeah, that didn't lead to a contradiction. Oh, 7 has to be here. Interesting. Where can 7 be in row 6? 7 cannot be any of these because we are guaranteed a 7 here. If 7 were one of these two, this would see at most 1, 2, 3, and then 8, 9, which is 5 cells, so that's not possible. So 7 has to be here, which makes that 7. This is 8, so yellows are guaranteed to be highs, and pinks are lows, which means this can't be 7. This can't be 7. So this is 8, which eliminates 8 here. That's 7, 9, which means this can't be 9. That's 8. 9 can no longer be here. This is 9. 7 has to be here, and that must be 8 for this to be seen. So it does not see either of these. Remaining digits, okay, in box 4 are 1 through 5. Okay. That means if this is high, it cannot be 8. 7 can't be seen, so this does not see either of these cells. Hmm. Remaining digits in row 6 are 1 through 6. No 5 or 6 there. That seems fine. 8 eliminates 8 from being here. Okay, and this can't be 8 either. No 8 there. Let's change these colorings because it's hard to see. So that's pink. We'll make this yellow. This can't be 8 anymore. So 8's either here or here. That's interesting. No 7 here because of 7 in the row. If this were high, can't be 7. Be 6, 8, or 9. It's one of these 3 digits here. If it's low, then, okay, so if these are high, that's 9 here and 7 here, which means this could not be 3. This would be 7, so that would be 1 or 2 in that instance. Interesting. Uh, 6 cannot be here, because if 6 is here, that would only see this cell, the 1, 2, 3, 4. And 5 can't be there for this. 5 can't be there anyways. So 6 has to be one of these two. If it's here, that means these 3 cannot be seen. One of these is guaranteed to be low, and we have a 1, 2, 3, 4 in these 3 cells, which means the rest of box 6 cannot be low. So this is not 2, 3, 4. So it's 5, 7, or 8. This must be 5, 6, 7, 8, 9. No 6 or 8 here. No 6 here. Where is 6 in box 6? It must be here. So this is 6 here, which means pinks are high and yellows are low. 6 is here, which forces this to be 1, which means this is 7 or 9. This can't be 1. No 1 here. No 9 here. No 1 here because of 1 in the row. That means none of these could be 1. This is 2, 3, and 4, which eliminates 2, 3, 4 in the rest of the row. So this is 1, 5, and 6 here. 6 here, 1 here. This is 7, 9. 7, 9 as a pair. We eliminate 7, 9 in rest of row 3. So this can't be 9. This can't be 7. This can't be 1, so that's 2, 3, or 4. We're guaranteed a 1 in row 3 in one of these two cells, which eliminates 1 in the rest of the box. No 1 here, which means where's 1 in box 3? It has to be here. Okay, 4 is one of these two. Hmm. 5 is one of these two, so 5 cannot be here. This is 7, 9 as a pair, which eliminates 7, 9 in the rest of the column, so this can't be 7 or 9. It's 8, which makes this 5, which makes that 7, which makes that 9. So that makes that 7, which is can only be 5 away from 2. So this sees 3 cells, 5, 7, and 9. So that's 3. 2 eliminates 2 here, so it's 3, which eliminates 3 there, so it's 2, which makes that 1. So no 1, 2 here, no 2 here. No 2 or 3 here. This is 4, 5. This is 4, 5. 5 eliminates 5 in the rest of this row. What 9 is one of these two. 2 eliminates 2 in the rest of the column. Okay. 7, we have a 2, 3, 4 triplet in column 9, which eliminates 2, 3, 4 in the rest of the column. So this can't be 2, 3, or 4. Can't be 7. It's 8, which makes this 9, which makes that 8. So no 7, 8, and 9 there. This 8 eliminates 8 here. 7 eliminates 7 here, so that's 9 and 7. This only sees 6, 8, and 9, so that's 3 cells. 7 eliminates 7 here. 8 eliminates 8 here. Which means where is the 8 in this box? It must be here. Where is the 7 in this box? It must be here. That leaves this as a 5 because of the 2, 3, 4 triplet in the box. So this is 5, which means this can't be 5 here, which means this digit is greater than this cell. So this can't be 4. 5 is one of these two, which means 5 cannot be here. 2 eliminates 2 here. So 5 is one of those two. We have 1, 2, 3, 4, 9 as remaining digits in row 5. 2 cannot be here, though. 3 can't be here. So this sees 3, 4, 5, 6, 7, 8, 9. That's valid. 4, 5, 6, 7, 8, 9. Valid. 5, 7, 9. 6, 8, and 9. These are 5 or more away from 3. Oh, this has to be 1. So this is 1, which makes that 2. There's no more 2 here or 2 here. We have a 3, 4, 5 triplet in column 1, which eliminates 3, 4, 5 in the rest of the column. So this is 1, which makes this 2, which makes that 1. There's no 1 here. No 1 or 2 here. Whereas this can't be 1. So this is 4, 9 as a pair, which eliminates 4 and 9 in the rest of the box. So this can't be 4. It's 5, which makes this 4, 3. 1 eliminates 1 here, so it's 5. There's no 5 here. It does not see the 1. It does not see the 5. It does not see the 9. So this must see 6 cells. So one of these is 1 or 6. It has to be 4, 3, 2 here to be able to see 6 cells. So 4 eliminates 4 here, so it's 3, which makes that 2, which makes this not 2 or 3, that's 4. 3 eliminates 3 here, so it's 2, 4, and 3, which makes this 1 and 2. No 3 here means this is 2. No 4 here means this is 3. This can't be 2, 3, or 5. It's 4, which makes that 5. So there's no more 4 here. There's no more 3 here. 1 eliminates 1 here, so this is 6 and 1. 6 eliminates 6 here, it's 3 and 6, which eliminates 3 here, so it's 9 and 3, which makes this 4 and 9, which makes this 5 and 4. Ah, I missed this one. I don't know how many of these, this one I missed, but this probably would have made things much easier if I'd spotted that earlier. Interesting. Yeah, the interactions between the skyscrapers and the Whisper 5 lines was pretty interesting. Um, yeah, I'm not sure how else to describe it, though. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.